Open full. Yay. Hi there. Apologies for the technical difficulties. I have yet to have a semester that starts right with all the tech. So I've been here 21 years. That should tell you something. Meanwhile, welcome to Calculus, you masochists, you. I'm Dr. Sassmore. My office is across the hall, across the street. I will rarely be there. If you want to find me, your best bet is the Math Enrichment Center on Tuesday or Thursday, or Monday, Wednesday, Friday, in this very classroom from 1:45 to 2:45. I have an office hour in here between my classes, and I have the Tuesday afternoon and Thursday afternoon after my classes over in the Enrichment Center. There's a virtual link here that is also available on our Canvas page. You can come to my office hours remotely should you want to do that. I did just make a seating chart most of the time. That will be the easiest way for me to take attendance. The only time that will change is when we have an exam, in which case I'll spread you out a little further. Other than that, if you change your seat, let me know. I'll just adjust the chart. We have plenty of room, as you can tell. This course is designed to cover chapters 2 through 6 of this textbook, Calculus with Early Transcendentals, 8th edition by James Stewart. It is unquestionably the most popular calculus textbook in the country. I don't care if you have an electronic version, print version. If you're going to do 3 semesters of calculus, we'll go through the entire text. If you're only going to do 1, you should rent it chapter by chapter or rent the single variable version, your call. This course covers both major objectives for mathematics and liberal arts curriculum objectives for mathematics. To that end, it is advisable that you hang on to some of your assignments from this course, as you'll use them both in your portfolio at Senior Stonian Seminar and in your justification for having addressed the liberal arts objectives here. And here's how we do that. %90 of the rest of this is boilerplate stuff I've been told I should put in my syllabus so that you all understand the way the class operates. If you're sick, stay home. If you have a cold, if the roads suck so bad you can't get here, send me an email. Let me know. I'm recording this. That means if you miss something, you can go back. There'll be a link to a YouTube playlist for the entire semester in that web link section of our Canvas page, and you can get any day you weren't here. On the other hand, being here is correlated with improved grades. People who are not here do worse, even if they go home and watch the video. I have had 1 student successfully complete one of my classes asynchronously. 1. 21 years. 1. Realistically, I believe that I add something to the learning process. If you could learn this all from a book, you could take a challenge exam. And then you would not need to take this course. Read the book, take the exam, you're done. I'm going to spend most of the semester interpreting that, because calc books are written by people who know what they're doing really, really well. And my goal is to turn that into English. I do take attendance in Canvas. The grade in Canvas doesn't count because it can't differentiate excused absences from unexcused absences. Don't worry about it. On my spreadsheet that I keep, your grade, and therefore on Canvas, will show a 0%. There's a 1% participation grade. That's where my attendance roster shows up. You need a graphing calculator. I don't care which version of a graphing calculator you use. I am most familiar with the TI versions, as long as they don't say CAS. CAS stands for Computer Algebra System. If you have a CAS calculator, it will do everything in this class. It'll do everything in the next semester too. You're not going to learn anything except how to push a button, and that doesn't help very much. If you've got a Casio or a Hewlett-Packard, that's fine. Just if you have a question about your calculator, come talk to me. We'll go through it. Please make sure you have the manual for your calculator. You don't have to have a TI. Casios are about $80 cheaper. Available at Walmart down the street. The bookstore has the TI versions. Get whichever one you like. During exams, you need something that is not internet enabled. So you can't use your cell phone. You can't use your iPad. You can't use your computer. I need to know what you know, not what Wolfram Alpha knows. And again, that means you need something that is a dumb device. I am going to assign homework and collect it weekly. Usually you will have multiple sections due on the same day. For example, here's the course schedule. Again, in that first module on our Canvas page, this is everything we're going to do all term. Sections 2.1, 2.2, and 2.3, a question and answer day. Those 3 sections worth of work is due on this day. What is due? Again, here's an Excel spreadsheet in our first module. What you actually have to turn in are these problems here. Now, you don't have to turn in Appendix B, Appendix C, Appendix D. As a matter of fact, if you look on our Canvas page, you'll see the homework problems listed here are already posted. Their solutions are already there because that's review material for the next couple of days. We'll talk about that. But these problems are the entire set of problems for that section. You only have to turn in these. Please notice something important all the way through here. 99.9% of those problems are even numbers. Why?
Because the answers are in the back of the book.
For the odd problems, not for the even problems. As a matter of fact, that is explicitly why these problems are even. Their answers aren't in the back of the book. But if you're looking here at Chapter 2, Section 1, Problem 2, and going, I don't know how let's even start this, then you look at Problem 1, whose answer is in the back of the book, or you look at Problem 3, whose answer is in the back of the book, and you say, oh, that's what they're doing. Complete solutions, not just answers, are in the library on reserve. I know if you spend about 3 minutes Googling, you can find the answer to any one of these homework problems. I know Chegg has them all. That part is not a problem to me because if you look at that answer and you copy it down, you'll get full credit here. And then you'll show up to my exam and have no clue what you're doing because you don't have anything to copy from. I know the easiest way to improve your homework grade is to go online and look at the answers. There is a clear and direct inverse graph as to how frequently you copy your homework versus your grade on the exam. The more you copy, the more that goes down. If you're going to be absent on a day an assignment is due, and assignments are always due after a question and answer period, you can scan and email me your assignment. The email is required to arrive in my inbox during the class period. If it's late, your assignment is late. Once the class period for which the homework is due ends, the assignment will be accepted at half credit. I'll grade it, and then I'll divide by 2. Each problem's a 5-point problem. I'll grade them all, tally it, turn it into a percentage. That goes into the Canvas grade. There's a fairly easy PDF conversion scanner. I've got a link to a document in our Canvas page, shows you how to put it on an Android or an iOS phone. Then you just literally one picture after the other and email it into me. As soon as we have a tutor, which should start as no later than Monday next week, I'll post an announcement for tutoring drop-in hours. All the tutoring goes through a Penji app that the Enrichment Center runs. There's a link to that app on our Canvas page. You can book tutoring sessions. You can just show up for drop-in hours. They're all listed on that site. I will have those listings as well, just no later than Monday. I am a Luddite in some fashion. I grade assignments on paper. If you don't like writing on paper and you want to write on your iPad, that's fine. Print it out to turn in. I want to collect paper from you. There are two very distinct reasons for this. I am a firm believer that is a very different thing to take a note with a hand, to write out something, than it is to type it out. Secondly, typing calculus is hard. Typing math in general is not trivial. Word does a disastrous job of working in equations. There are typesetting softwares for mathematics. The learning curve is a cliff. It isn't worth it at this point. So please make sure you bring paper on the day stuff is due. There's a printer at the end of the hall if you need to use it. Exams. There are 4 scheduled exams. Our first exam is February 12th. It's going to cover all of Chapter 2 and the first section of Chapter 3. You should endeavor to take all 4 of the exams. 1, 2, 3, 4. However, stuff happens. You're on your way into class the morning of the exam, and you get a flat tire on Route 30. Given the relative occurrences that I see, relative frequency that I see, people off on the side of the road, that's not an uncommon thing. You send me a message. If you call my office phone and leave a voicemail, it will convert it to an email and email me the recorded message. Call me. Hey, I'm stuck on the side of Route 30. I'm not going to make it for the exam. I'll get you makeup. If you have any advanced warning that you're going to miss something, we'll work it out so you can take the exam in advance. It's easier, in my opinion. Get it out of the way before you have to go to whatever event you have to go to. You wake up the morning of the exam, I'm not feeling this, I can't do this, this is, no. That's not really a good excuse for makeup. If you do not arrange for or provide documentation for makeup exam, you will not be able to take one. The grade from the next regularly scheduled exam will substitute for the missed exam. So you could skip exam 1 and double up exam 2. On the other hand, doing so, please note that each of the exams individually is only worth 17% of your grade, but that would turn one exam into 34% of your grade. You'll wager a third of your grade on 1 hour. I don't want you to do that. I think that's not a good idea. So I would recommend that you endeavor to take all the exams. This is the grading scale. The grade in Canvas for the last couple of years has been really damn close to the grade I keep in my Excel spreadsheet. Everything is computed numerically, rounded to the nearest whole number. If you have an 89.51, that rounds up to a 90, you get an A-. There are no individual assignment curves. There may be a curve after the final's graded, but I won't know until then. As I said earlier, I am recording this. I haven't had people on quarantine in a while, but if we all start seeing COVID show up again and we have to quarantine out, then I can actually broadcast this as well as recording it. If I'm going to be stuck at home, I'll do that as well. I had that happen to me last spring, and I was home for 4 days and I just taught from my desk. If you have an art portfolio, a musical instrument, a large athletic equipment bag, please make sure it's up against the walls or under the table so it does not impede the aisles. In an emergency, our exit is literally right here. Down the stairs, 2 flights across the street is our meeting place. I hope we never need it. You'll get feedback in Starfish at least 3 times during the semester. There are 2 required Starfish reports at 5 weeks and 10 weeks and midterm grades. In the middle, if there are issues, you'll be tagged in Starfish. If there are benefits, you'll be tagged in Starfish. Make sure you check Starfish occasionally. Your best point of contact with me, I know I'm an old person, is email. Why? Because it leaves a trail. It leaves a record. Send me an email, I'll respond to it. I have it, you know what was said, I know what was said, we've got it written down. Rather than texting me, dropping into the Discord channel for this course, Discord server, that's fine. Email leaves a trail. And it's the way I'm going to send out contact to you all most often. Please note, I do try and go to sleep, so I don't necessarily answer my email after about 9:30 at night, but I guarantee you a 24-hour response time. You've got the schedule, you know when we're doing what. There are no extra credit assignments. There are some bonus problems on some homework assignments. There are some bonus points available on exams. At the end of the semester, when May rolls around, if you tell me what can I do to improve my grade, I'm going to ask you if you have a time machine. Start now. During the lecture, some of you may grasp the material faster than others. I tend to look for faces that look at me like, huh? And talk until that expression goes away. So if you're looking at me like, will you just get on with it already? It's because somebody behind you is looking at me like I'm speaking in Farsi. Make sure you have a valid email address in GriffinGate and in Canvas. By default, that is set to your university email account. That's a Gmail account. You can set it to forward to wherever you want. If you're happier using a different account, that's fine. But I'm going to send stuff to the university accounts. If you send me an email from your personal account, I'll respond to it. But when I go to send something to you, I need to use the account associated to your school address. I won't remember who countrybutterfly25@yahoo.com is. Make sure your phone's on vibrate or silent. I know it's a 50-minute class. Once you have electronic versions of the textbook, you'll be buried in your computer anyway. But if your lap is glowing, I'm going to wonder what's radioactive in your pockets. And, you can hopefully refrain from texting for about 50 minutes. Unless you have a documented hearing issue, please take your earbuds out. Thank you. This is a no smoking room. It's a no smoking building. No smoking on campus within 25 feet of an entrance. I'm sorry if you miss it. Nicotine therapy is available in the health services area if you really need to, admin 513. I am a mandatory Title IX reporter. If I see something, if you tell me something, I am required by law to send that up to our Title IX coordinator. Don't let that stop you from talking to me if you want to talk to me about something. If you don't want to talk to me, if you don't want the Title IX coordinator, here are some counseling centers and therapy centers to talk to people who can make a difference. And trust me, they're good people to talk to. Disability services. If you have legally required accommodations, you need to let me know as soon as possible via the Accommodate system, which means you need to go up to the Student Services Office and have them approve the accommodations listings, give them all of the medical and documentation that you've got. They'll send me, this is what you're required to do for these students. I don't need to know why. I just need to know what I'm required to do. You and I will have a meeting. We'll discuss what needs to be done and how we're going to reach your accommodations. Ideally, I'd like that to be done by the end of next week if possible. Academic engagement. Come to class, try not to snore if you fall asleep. Try to pay attention. I believe it helps. Most of the time, I see a positive correlation between coming to class and grades. If you have a problem with the type of engagement I am seeking, I'll ask a question and just sit here waiting, staring at you all. I would like to talk to more than one person in the entire semester, so everybody should jump in. Throw your hand in the air and let me know what's going on. To the extent that you have sporting events or other class-related events that take place outside, we'll work out how to accommodate those as well. And last, but by no means least, academic honesty. Don't cheat. Okay, but what does that mean? Well, I've already talked about homework assignments and that sort of idea. It says here, non-sanctioned collaboration. I want you to work with each other. I think that's helpful. If two of you are working on the same problem and one of you misses something and the other one says, hey, wait, what about this? That's helping each other learn the material. On the other hand, if you do problem one and you do problem two and then you swap, did you learn or did you copy? When it comes to exams, I want everybody to do their own work. But when it comes to homework, I want you to work with each other. That's our sanctioned collaboration. To the same end, as I said earlier, Wolfram Alpha, Chegg, ChatGPT, I've been dealing with AI solving problems for 40 years. It's not new in math. One of the most famous proofs in mathematics was decided by a computer in the late 80s, called the four-color theorem. Interesting diversion for a second. Make a map. Whether you make it on a globe or a flat piece of paper, doesn't matter. 3 rules. Each country is a self-contained section, has no satellite pieces, and no country is completely contained within another. And 2 countries share a border if they share a section, not just a corner. How many colors do you need to make sure that no 2 territories that touch each other are the same color?
Maybe 2 different colors, like 4.
The answer is 4. But it took over 100 years to show that it wasn't 5 and that it actually was 4. And it turned out that the proof by Haken and Apel back in the 80s reduced this to 300,000 individual cases and proved each one by running it through a brute force calculation on a computer. Since then, refinements in computer programming and in the way this proof is looked at have taken this from 300,000 cases down to about 15,000 cases. But it was a very difficult proof to be accepted because of how technologically aided it was. It wasn't as nice and clean and elegant as some of the proofs, some of the results we will show to be true in mathematics. Since then, larger and larger problems with more and more specific detail have been proved technologically and addressed computationally. That's part of the comment about cell phones. Questions? Then let's dive in. Okay, appendices B, C, and D go back through some of the algebra and trigonometry topics that we are going to assume as background knowledge. Unfortunately, Bailey, the wind is going to suck all semester long. One of the revisions for this room is some heavy curtains to go in to deaden the wind, but with the air conditioners placed in the windows, they cause extra turbulence. That whistling sound, we're stuck with it. There were a couple of days last year where the entire room rattled because of how bad the wind was. And you should have been in here yesterday morning when the snowstorm came through. It was not fun. I was downstairs in a room, and the windows were still rattling down there. So, we'll start with Appendix B. Which deals with coordinate geometry. So, the primary method by which mathematics was done for most of written history is geometric. It wasn't until about the 1400s that we codified algebra in any real sense, which stems from the translation of an Arabic book, The Method of Completion and Reduction, Al-Yabar et al-Muqabala. Algebra, Al-Yabar. So almost all of the development in between was based on geometric ideas. And René Descartes, in the mid-1500s, decided one of the best ways to address this was to relate our geometric ideas to our algebraic ideas. And so we have what is called the Cartesian plane, or the coordinate plane, which relates every point on the plane to a pair of numbers measuring from some crossing point, O, the origin. We measure the horizontal distance, positive to the right, positive up for the vertical distance, and we come up with a pair of numbers that tell me where that point is. Given that information, what can you tell me about the numbers A and B in this picture? They're both positive. We are to the right of the origin. We are above the origin. Both of these are positive. As a matter of fact, any point in this quarter of the plane will have that same property. We're going to call this quadrant 1. If you think of extending these axes infinitely, we can divide up the plane into 4 quadrants, and we'll number them counterclockwise. And then we can say, oh, based on which quadrant I'm in, I know the signs of the numbers of the points there. Here, both A and B are bigger than 0. That's our first quadrant, to the right and up. What about quadrant 2? What changes there?
Become plus and 0.
But B is still positive because we're still up. Now, please notice that the dividing line, the vertical axis I've labeled Y, has A being exactly equal to 0 there. It's neither in quadrant 1 nor quadrant 2. So the points on the axes don't belong to a quadrant. Down here in quadrant 3, what do I have for signs?
I have a negative to the vertical point downward again.
Keep
It
talking.
could be negative, and my B is going to be still less than 0 because they're both negative, the X and Y.
I'm to the left and I'm down. And then in quadrant 4, I've moved back to the right, and so now my A is positive. And we can describe sections, sets within the plane by relating values for X and Y. So I could describe a set by giving you an equation. Hey, here's the set of points where X is equal to 1. Well, that set of points describes an image over here. And if I know where the point 1 is along the x-axis, I want every point whose x value is equal to 1 that describes a vertical line. If I said, give me every point where x is less than or equal to 1, well, then not only would I want that line, but I'd want all the points on the left of it as well. And I could shade that in to describe a section of the plane. But as my equations grow more and more complicated, the pictures will then grow more and more complicated correspondingly. But even if I'm just working with a couple of points, point 1, point 2, Let's draw those 2 points on this coordinate plane that I put over here on the left. Point 1, -2, 3. A is negative, B is positive. That's going to be in quadrant 2. Five, -2, positive A, negative B is going to be down in quadrant 4. A question. How far apart are those? How do I figure out how far it is from point 1 to point 2?
I have to use the distance formula that d equals the square root of x2 minus x1 squared plus y2 minus y1 squared.
Whoa, that's a complicated formula. It is correct, but my question is, where did that formula come from? In one sense, yes, but only in the fact that it's an algebraic formula, and I can therefore say, oh, it's got to be in Jamar's book somewhere. Aha. Let's draw a right triangle with a vertical leg and a horizontal leg, parallel to the y-axis, parallel to the x-axis, whose hypotenuse connects these 2 points. So if I say, all right, what I'm really going to do is draw the connection from point 1 to point 2, and then I'm going to draw straight down from point 1 and straight across from point 2. Then I have a right angle here in this corner. That's a right triangle. Pythagoras tells me the length of the hypotenuse squared would be this distance squared plus this distance squared. Then I take the square root to find out this distance. Oh, from here to here, that's a change in x. From here to here, that's a change in y. Now, I didn't specify which one was 0.2 and which one was 0.1. Down here, when I said x2 and x1, I just have to keep that consistent here. I do have a 1, I do have a 2. As long as I stay in the right order, these distances should be positive. So I'll make them positive. I'll put an absolute value there. But even if they were negative, what happens when you square a negative? So I can lose that minus sign even if the numbers in here end up being negative. So in our case, -2 minus, oh, that's y. So let me do the right order. 5 minus -2 squared plus -2 minus 3 squared, all square rooted. So here I have a positive 7. Here I have a -5. So that's 49 and 25, 7, let's see, 50 and 24 is the square root of 74. I have absolutely no idea what the decimal version of that is. I'm going to say it this way. I'm not sure I care. Leave it as square root of 74 and I'll be perfectly happy. Let's see, 64, square root of 64 is 8. Square root of 81 is 9. This is between 8 and 9. Grab your calculator, it's like 8.6-ish. Good enough. So while there is an algebraic underpinning to all of these, I like to think of this visually, geometrically, and see what's going on here. But I'm a very visual person, and I know a lot of people who do math are not, and actually get upset with me when I try and draw things more than explain them algebraically. That's okay. If you want to simply remember this formula, go for it. I prefer to draw that little right triangle that Jackson mentioned. All right. Questions? Take the hypotenuse of that right triangle, extend it. You get a line. Now, how could I find an algebraic expression that would describe that line in the same way I described this one up here? This is another case of chicken and egg idea. In some sense, the equations came before their visual interpretations, and in some cases, the visual interpretations came before the algebraic expressions. I saw a hand start to go up.
Say we're going to find the slope of the line.
Aha. Here's an interesting idea. What do you mean by slope?
I have to find like how far, like slope as in you're going to some points. I'm blanking here.
That's okay. But I need to, here's a very interesting concept. What you just did with your hand is a perfect example of an intuitive definition of slope. It's going this way, right? As I go from left to right, the line is either falling or rising or steady. And so I can have this intuition. It's going up, it's going across, it's going down, maybe it's going straight up and down. That slope idea. It turns out that same intuitive idea is exactly backwards from one of the historical developments of slope. In Egypt, the Babylonians and the Egyptians measured slope the other way. Consider the surface of the book as our line, right? As we go from left to right, it's falling. What they did is they took their tool and put it on the surface and measured this, sticking out from the surface, and said that's slope. So to an Egyptian, this line that we've drawn right here is going this way. That's perpendicular to what we think of as the right idea. And we would call this a normal or a perpendicular rather than the slope, but they measured it differently. They obviously knew what they were doing. They managed to build the pyramids with this idea, but it's a different behavior. So if I want to measure that sort of change, am I rising or am I falling as I go from left to right? I want to look at these distances again. But instead of looking at them independently of one another, I want to take their ratio. And so we define a slope as our change in y over our change in x. You'll often see this called the letter m. That's stolen from the Germans. The German word for slope starts with m, I think, but that's where I got it from a German text. With that in mind, I can find the slope in this case. And I get a negative number. Because my change in y, -2 minus 3 over 5 minus -2, -5 over +7. And so now I can say whatever the expression is that relates all of the x's and y's on our line, they should obey this. But there's more. I want them to be on our line, which means not only do they have to have this slope, they have to have it in relation to one of these points. And so what I can say is that if you picked any x and any y, then you have to pick one of the 2 points. Somebody tell me, you want to use point 1 or point 2? Point 1. -2, 3. Then I know that the arbitrary point we picked should have this slope and be related to point 1. Now, division bothers me a little. So I'm actually going to take the x part that's down there on the left and move it over to the other side. I'm going to write this like this. It's minus a -2. I just turned that into a +2. And now I have what is called the point slope equation of the line. In general, I'm using something that looks like this. Y minus y1 equals m, x minus x1. M is the slope we found. x1 and y1 are one of the points. It doesn't have to be point 1. It could just as well be point 2. But that means that this version of a line isn't unique. Because I could use either point and it would still work. Turns out, if I multiply this out and get y all alone, three is 21 over 7, so I have minus 10 plus 21 gives me plus 11 over 7. This is unique. So if I write y equals -5 over 7x plus 11 over 7, no matter which point I started with, I will end up with this equation, regardless of if I used point 1 or point 2 at the beginning in our point slope form. You should check that. Try it with the other point, make sure you get the same spot. This is a different equation. It's got the same slope, but it's got a different number on it. What's that 11 over 7 represent? Because if I put in x equals 0, that gives me a y value, and we said that x equals 0 was the point on the y-axis. So we'll call this the slope-intercept form of the line. Almost always we write that as mx plus b, assuming that that b is the y part of our y-intercept. I could just as easily rearrange this even further, put the x and the y on the same side. I don't like the fractions. I'm going to multiply everything by 7. Again, this is still the same line, but it's a different equation. And again, this one isn't unique. I could have multiplied by 14. I could have multiplied by -7. But this is called the general form of of a line. And it's usually written AX, BY, C. Sometimes we even move the 11 over as well, set it equal to 0. When you get to solving simultaneous equations, again, we did that in algebra, 3 or 4 equations in the same variable, 3 variables, or 2 equations in 2 variables, we tended to write them this way. Method of elimination by addition, method of substitution. This was easier there, sometimes. In order to draw a picture of a line, you need 2 points. If you're in slope-intercept, you already have one of them. The y-coordinate of the y-intercept is right there in the equation for you. You should find another point. Well, if we found the y-intercept by putting in x equals 0, then we can find an x-intercept by putting in y equals 0. And we can do that for any version of our equation. If I put in y equals 0 here, get x is 11 over 5. Well, now I have x is 11 over 5 and y equals 0. That's a point on the x-axis. I have 2 points. Here we go. And as a matter of fact, if I go back to my mediocre picture, 11 over 5 is 2.2, right? A little bit bigger than 2, where I crossed the x-axis. Not bad for a half-assed drawing this morning. I did mention a word earlier, though. I mentioned the word perpendicular. And I mentioned it as pointing out from. But perpendicular is a little more specific than that. Perpendicular points out at a right angle, makes a 90-degree angle. How do I tell from this equation whether lines are perpendicular or not? I need to look at their slopes. If I have 2 lines, I'll have 2 slopes. And I've written them in slope-intercept form. If those 2 slopes, when multiplied together, give me a -1, then my lines are perpendicular to one another. If those 2 slopes are the same, then those lines are parallel to one another and will never touch. Now, there are other options. Lines that cross but not at 90 degrees are just said to be oblique to one another. So the only thing that's special is crossing at 90 degrees. We will hide information about lines, about slopes, by using parallel and perpendicular frequently. All right, I'll do the other 2 review sections tomorrow. Remember, this class does meet 4 days a week, Monday, Wednesday, Friday at 9:10, and Thursday at 8. So I'll see you all here tomorrow morning at 8 o'clock. Have a wonderful rest of your day, everybody. End recording.